is also 5!
I'm so excited.
I'm so alive!
For this practice test.
Oh, it's chapter 5!
Is it 1? No, it's not 1. Is it 2? No, it's also not 2. Maybe it's 3. We just covered it a second ago. It's definitely not 3. But it's gotta be 4. It's not 4.
It's 5!
Hello, Mr. Barbera again. Let's go ahead and do the chapter 5 practice. Show me what you can do. Practice test. So we got standard number 1 here. It says I can solve percent problems using equivalent ratios. You don't have to do ratios for these, but we can. It says Mr. Goldman bought a new porcelain doll of himself at a 20% off sale and saved $12. What was the regular price of the mug? So what I'm going to go ahead and do with this one here is I'm going to draw a number line. And we know that this would be 0% and this would be 100%. And we don't know what 100% of the price is. But we know that when we saved 20%, which I will label this way, and we know that that means that we paid 80%. We know that the amount that we saved was $12. So what we've been saying is the ratio of the number of dollars here to its percentage is going to be the same for every other dollar amount to its percentage. So if I want to know the regular price of the mug, that's 100% of the price. I can make a ratio where I say, okay, 12 over 20% is the same as something over 100%. And right now you can just use giant ones to find this. So I would go ahead and I would just use the giant 1, and I would say, okay, I need 20 to be 100, so I'm going to multiply by 5, which means I need to multiply the top also by 5, and 5 times 12 is going to be 60. So that one's going to be $60. Oops. Also, if you wanted to break this down to 10%, I could have divided this by 2 over 2, and that would have given me that $6 was 10%, and you could also work your way up. But in this case, 20% worked really nicely. Let's look at the next one. The next one we might have to do a little bit of that. So, Mr. Barbera reduced the price of his sweaters, knit from hair he found at the park, by $18. If this represents a 15% decrease, how much did the sweaters originally cost? So same idea on the number line. 0, 100%. I'm decreasing the price by 15%. So that means I'm paying, or people are paying 85%. And we know that that decrease was an $18 decrease. Oh, a little off on the side there. Sorry about that. So I'm going to say $18 to 15%. And we need to make that into 100%. Now, 15% is a little tougher because there's not an easy or an obvious number for me to multiply 15 by to get to 100. It's not an integer. It's going to be some sort of fraction. Actually, if it's going to have 2/3 in it. So 6 2/3, I think? Okay, I'm sidetracked. All right, so what I like to do is I like to break this down into a smaller piece that I can deal with. So I can break this down into 5% really nicely by dividing it by 3 over 3. Because I know that 15 divided by 3 will give me 5. So now I know that 18 divided by 3 is 6. So what I've just shown right there is that if $18 is 15% of the price, then $6 is 5% of the price. And now I can build back up because 5% times 20 gives me 100. And I'm sorry that I'm going to kind of run into this here, so I'm going to try to squish it down just a little bit. So I'm going to multiply by 20 over 20. That'll give me 100% on the bottom, which is what I'm looking for because I'm looking for the original cost. And on the top, 6 times 20, I have to think about this one for a second, 120. So the original cost in this case was $120. Okay, cool. Let's move on to number 2. Okay, so number 2 here is I can develop and use a probability model for a single event. The probability model, like we've seen on Con, is usually, it's all the probabilities in a sample space. So we know that the probability model, everything needs to add up to 100%. In this case, what we're asking you to do is just to find the probabilities of specific events. And then by doing that, you'll have to find that. You'll basically be establishing the probability model. So drawing an even number diamond from a standard deck of cards. There's two things happening here. We have even number and we have diamond. So if you remember from a deck of cards, there's 52 cards total. There are 4 suits, and diamond is one of those suits. So each one of those suits has 13 cards in it. And those cards are 1 through 10, and then Jack, Queen, King. Remember, we don't worry about the jokers when we're talking about a deck of cards. That's only for certain specialty games and stuff. Okay, so we're going to talk about drawing an even number diamond. So if it's an even number, or actually let's talk about diamond first. If it's a diamond, we know we're only talking about one of our suits. So now we're down to only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King of diamonds. So we only have one of each of these right now. And then it says an even number. So I'm going to look in here and I'm going to find all the times I have an even number. And the Jack, Queen, and King don't really have a number associated with them for these purposes. So I have a 2, 4, 6, 8, and a 10. So that's 1, 2, 3, 4, 5. And there's still 52 total cards in my deck. So the probability would be 5 out of 52. And if I could, I would simplify that, but there's nothing I can do. Okay, rolling a prime number on a standard number cube. Okay, so a standard number cube means a 6-sided die. So on a 6-sided die, we have 1, 2, 3, 4, 5, and 6. We're talking about prime numbers. We've talked about this a lot in class. Is 1 a prime number? No. Yeah, it's not a prime number, right? So we've talked about that. 2 is a prime number, though. That's one people always forget because it's the only even prime number. 3 is prime, and 5 is prime. Probably should take a minute to remind you. A prime number is a number that's only divisible by 1 and itself, but also it's not 1. That's like part of the definition. So I have 3 numbers here that are prime out of a number cube of 6 sides. So 3 out of 6. And then I would simplify that to 1/2 because 1/2 of the numbers on the die are prime. All right, last one for this section. Drawing a red marble from a bag of 120 marbles, 45 of which are red. This one's really handed to you here. If there's 120 total marbles and 45 of them are red, that's just going to be 45 over 120. And this one we can simplify too. Off the top of my head, I'm not sure if there's a number bigger than 5 that goes into them. But so let's start with 5. 5 goes into 45 9 times. It goes into 120 24 times. And now it looks like a 3 goes into both of those. Is that right? Yeah, I guess it is. Okay. Divide by 3 over 3. And I get 3 over 8. So actually, quick little tip here. Because I divided out of 5 and a 3, that means what I could have done in the beginning is I could have divided out of 15, because 5 times 3 is 15. Maybe think about that one for a second. All right, time to move on to number 3. All right, standard 3. This one is about creating probability models for non-uniform events. So the non-uniform aspect means when the probabilities of each event are not the same. So instead of being like the number cube, where 1 through 6 all have the same chance of coming up, here we're talking about a spinner that has different probabilities for each section. So the red section is 3/8 of the spinner, the blue is 1/4, and the green is 5/16. What is the probability of spinning turquoise? So there's, I left out that there's 4 sections. So we're not telling you the turquoise side to start. So you have to figure that out. So the first thing you need to know is, what do all the probabilities in the sample space need to add up to? And if I have a spinner, and I add up all the sections, so I'm not even going to cut them up, if they're all included, this would be 100% of the options for what I could come up with. So in total, all my probabilities need to add up to 100%. Or if we're talking about fraction form, it would just be 1. So what I'm going to do here is I'm going to take the probabilities that I have, 3/8 for red, 1/4 for blue, and 5/16 for green. And I'm going to go ahead and I'm going to add them all up. Because once I add them all up, I can take that away from 1, and that'll tell me what turquoise is. So
I'm going to add these three here. Need to do a little work. So common denominator is 16. I'll multiply this by 2 over 2. That'll give me 6 over 16. I'll multiply this by 4 over 4. That'll give me 4 over 16. And the 5 over 16 stays the same. So when I add these all up, 6 plus 4 plus 5 is going to just be 15 sixteenths. And in this case, it's actually pretty easy to see, but I'll still show you the work. What I would then do is I would take one whole, which is 16 sixteenths, and I would subtract the probability that I just found for all the other sections. And whatever's left over, that has to be the turquoise. So the probability of turquoise is that 1/16 left over. Pretty small sliver of that spinner. All right, continuing on here, what is the probability that on any turn you will not get red? So remember, if something is... The probability of getting something and the probability of not getting something covers all the possible outcomes, right? I can either get red or I can not get red. That's the only two options. So that means that, again, the probability of red and not red needs to add up to one whole, or 100%. So if 3/8 was red, I need to subtract that from one whole, and I find out that 5/8 would be not red. And the other way you could do that is actually if you add up the other three sections. So if I added up 1/4, 5/16, and 1/16, I would also get 5/8. You could check that on your own. All right, let's move on to number 4.